Climate change is the greatest global challenge we face today, and it requires action from all countries and all sectors of society and our economies. For many years, space-based systems have been critical to developing our understanding of this vitally important and difficult problem. They enable observation of numerous aspects of our planet, allowing us to map our global environment and ecosystems. They also allow us to identify trends and understand how and why our climate is changing. And as technologies advance and ever more effective and accurate sensors and systems allow a greater understanding of our climate, the role of space in addressing climate change will continue to increase. In 2020, the National Space Council was established by the UK government to enhance the UK's strategic consideration of space and set a new direction for our space policy. Improving our understanding of the future opportunities that space technologies can provide to help address climate change will be a core part of this work. Developing the UK's space strategy is an exciting moment of opportunity to develop this growing sector, and there is so much energy, effort and enthusiasm in government to make this happen in the summer. Our forthcoming space strategy will outline the government's response to the growing strategic importance of space to our country's interests, and also it will address the changing nature of the global space sector. It will be the first time that here in the UK we will have constructed a national strategy that brings together civil and military space policy together. This strategy will provide important cross-government strategic direction to future space activities and investment. It will unite our government behind a clear vision for the UK in space to ensure that the UK can establish itself as a global player in space and seize the economic opportunities that this represents. To enable our space sector to continue to thrive, we must ensure that the UK remains at the forefront against climate change. We need the right homegrown skills and expertise to support the future talent flow. My colleague Grant Shapps, the Secretary of State for Transport, announced the launch of a new NanoSat competition. This will invite groups and individuals to compete for a £600,000 prize fund to develop and manufacture a nanosat that can be used to inform innovative solutions to help support our climate change ambitions. All entrants will have the opportunity to benefit from expert guidance and mentoring to help develop their proposals and their talent. This will help to ensure that the UK has the right skills and the critical knowledge to cement our position as a world leader in space, not just for today, but for many years to come. Today, you will have the opportunity to hear from world-leading experts and climate scientists from across a variety of fields about how we can tackle the climate emergency. The space community, our experts, our talent, our people are at the heart of this fight, and they are working together to protect our planet for generations to come, while also driving prosperity and providing economic opportunity for the people across the United Kingdom. Thank you.
For centuries, the UK has played a leading role in observation, exploration, and discovery. Today, we're part of a new space age. The UK space sector's unique strengths have helped intercept comets, journey to the sun, and contribute to missions to help look for signs of life outside Earth. We're growing fast, levelling up the economy, employing tens of thousands across the UK and generating billions in income. And this is just the beginning. The UK Space Agency is growing innovative businesses and highly skilled jobs, boosting research, development and productivity nationwide, and ensuring resilient UK space capabilities to protect our way of life. We're kickstarting the first satellite launches from UK spaceports, leading the world in building and launching small satellites and bringing exciting new businesses to the UK, heralding a new era for the UK space industry. We're using space technology and expertise to benefit our planet and its people by monitoring environmental damage, understanding and tackling climate change for a greener future, innovating healthcare to save lives, enabling better communications to help people connect, making transport safer for all, tracking disease, improving crop growth to tackle hunger, and responding to natural disasters across the globe, while ensuring space remains a sustainable environment for the future. We're inspiring stars of the future, laying the foundations for careers in space with training and apprenticeships, and strengthening the reach and diversity of the UK space industry. In delivering the government support and backing, we're bringing our powerful global voice to institutions, space agencies, companies and academics all over the world. And with a diverse and inclusive space sector, we're inspiring and leading the UK in space, looking towards a greener future and making people's lives better every day.
Small satellites will play a crucial role in the fight against climate change, providing us with the knowledge and data to overcome local and global challenges alike. Real-time satellite data is already improving how we tackle global issues such as deforestation, sustainable food production, and disaster response. These same satellites will also help us monitor ocean health and illegal fishing. It is wonderful to see how Earth observation and satellite applications are helping us inform our actions, restore nature, and protect businesses and communities from the impacts of climate change. The environmental intelligence gained from satellite data will be key in shaping policy to meet our global carbon reduction targets. Satellites provide much-needed assistance in environmental monitoring, and the latest generation of small satellites promise even better quality information to ensure we really understand the issues at hand. Low Earth orbit satellites will play an important role in connectivity because they can offer low latency and they can help keep remote communities around the world connected. They are a great complement to the larger geostationary satellites and ground networks. In addition to providing more accurate and frequent data to support the rapid expansion and needs of the world we live in, the next generation of small satellites will be able to connect and help people in remote places that need it most. That's why at Virgin Orbit we are on a mission to provide dedicated and responsive access to low Earth orbit, leading the way in responsible launch and expanding that to Cornwall soon. As we get closer to launching from UK soil, I'm getting more and more excited about the possibilities and benefits that increased launch capabilities will bring to life on Earth and the protection of our beautiful planet.
For decades, as individuals, we've consumed the world's resources without even thinking about it, because from our perspective, we're just having a very small impact. But when you multiply that up to the whole population, then the effect that we have on the Earth is huge. It's always amazed me that, from the ground, our view of the world is restricted, but you only have to go a few meters up and your entire perspective changes. And so that different view that you get allows you to contemplate things in a completely different way. Of course, if you take that one step further and go into space, then the perspective we get is a global view, and we're able to see and monitor and really discover about the resources and the scale in which we're using the resources of the planet. So space is a really vital location from which to look after our planet, to understand what's going on, and start to be able to scope out what we need to do to make that difference, to reverse global warming that we're all responsible for. So exploration of space and planet Earth from space has been the domain of space agencies and governments. So for example, the European Space Agency has its series of Sentinel satellites, and they monitor the Earth and send down the science data, which then is freely available to access to essentially analyse what's happening here on Earth. But more recently, the cost of accessing space has come down significantly, and that means that companies can come into existence to do the exploration of space and the exploration of the Earth from space. That's enabled companies like Planet to come into existence, and they are now photographing the Earth from many different small satellites in low Earth orbit. Those images are actually downlinked here at Goonhilly, and they help to monitor the environment and help us to understand what's going on. As we, as individuals, try and assess what we can do to understand the issues of climate change and do something about it personally, we're very proud at Goonhilly that we are able to support companies that are supporting Earth observation, but also we've invested ourselves in a Space AI Institute. We've built a state-of-the-art data centre with high-performance computing, and this allows us to use new techniques of computer science and signal processing to examine the data that's coming from these satellites and really pick out the fine details of the changes that we as individuals are making.
As we at Goonhilly Earth Station Limited develop these new techniques and innovate in order to deliver space communication services, we strive to achieve this with a sustainable approach in mind. By continuing to drive innovation and taking our research and development through to deliver market-facing services, we are continuing to grow quickly as a business. And we are not alone in that respect. The space industry continues to grow both in the UK and overseas, creating the exciting employment opportunities that are needed to drive our economy and to focus on delivering solutions for Earth based on data from space. Communicating with space, whether for deep space missions or for communicating with an increasing number of low Earth orbiting satellites, together with the processing of data sets collected, all requires power. Our approach to a responsible use of the energy required includes a combination of green grid sourcing, an increase in our own on-site renewable energy capability, and a continuing and balanced refresh of hardware to improve energy efficiency and reduce consumption levels. Over the past few years at Goonhilly, we have been working tirelessly to become the world's first privately owned company to support deep space communications. And, after a monumental effort lasting 3 years, these complex projects have been achieved in a highly sustainable way by the repurposing of 2 of our largest antenna assets. This focus has enabled us to create a new and exciting market capability through a combination of the upgrading of the assets and by building on the existing capabilities and skills of our engineering teams. The new lease of life provided by repurposing these antennas has involved a major recycling program where systems have been changed and enhanced by groundbreaking technological advances, further contributing to growth opportunity. One of the capabilities these assets now have, through the sustainable upgrade to the structures on Earth, is the ability to support space situational awareness. Space debris is a mounting issue in space, and perhaps fittingly, these antenna assets now have the capability to assist with this problem and protect the satellites in space that we rely on for critical information. And, as our knowledge of deep space communications and antenna design has developed over recent years, Goonhilly is now looking at even more efficient ways of expanding its space communications capabilities. At Goonhilly Earth Station, here on the Goonhilly Downs in Cornwall, at the southernmost point of the United Kingdom, we are fortunate to enjoy and sustain the delivery of groundbreaking technology within an exceptional natural environment, which is classed as an area of outstanding natural beauty and a site of special scientific interest. As we continue to develop space sector solutions, we can be confident that our engineers and the next generations of space engineers are needed to contribute to developing the solutions required for such areas to be preserved and on a bigger scale for planet Earth.
With the space sector having such a crucial role to play in providing solutions for those environmental challenges, those facing us now and for generations to come, it is exactly that next generation of scientists and engineers who need to get involved. Today's children and young people are not only acutely aware of the challenges, they also hold the key to potential solutions, whether those work from the ground or are based in space. At Goonhilly, through various programs, we strive to inspire these future leaders into STEAM, that's science, technology, engineering, arts and maths, and to give them the motivation and basic tools to join us in the space sector, to come up with new innovative approaches to existing and future environmental challenges so that we can all be part of the solution.
Welcome to Cornwall. We are so excited to have you here for G7. My name is Melissa Thorpe and I'm the head of Spaceport Cornwall. And today I'm going to talk to you about responsible launch. I am so inspired by what is going on in the space industry and how environmental intelligence from space is benefiting us here on Earth. I believe launching satellites from Cornwall is actually going to be part of the solution and not part of the problem. However, the irony currently in the industry is that all this amazing technology is actually still being launched in a way that impacts the environment, and this needs to change. While images like this can help inform policymakers, for example, this image of northern Italy last year during lockdown clearly shows that impact that humans have with carbon emissions. This actually went on to lead to policymakers making changes to places like Venice and their tourism policies. So the power of space imagery really can impact what we do here on Earth. The satellite that took this image, Sentinel-5, was actually built in the UK, shipped overseas to a Russian cosmodrome, launched off the back of an ex-ballistic missile at a place where it's really difficult to find out about the local jobs, the environmental impact, the local community engagement, and this also needs to change. If our industry truly wants to be part of the solution, then we need to launch more responsibly. As commercial spaceports pop up around the world, looking very different from the spaceports of the past, there's an opportunity to launch differently, to launch more transparently, more ethically, sustainably, and responsibly. Here at Spaceport Cornwall, we want to take a global lead in responsible launch. We have several initiatives that is going to help us do that. The first is working with UK Space Agency on our spaceport license. This will include our assessment of environmental effects that will allow us to identify what our impact to the environment will be and then set a plan in place to mitigate against that. However, we want to go beyond this, and we're actually going to be launching our own sustainability action plan, an annual sustainability report, and an ethical framework. In this, we'll not only look at offsetting and mitigation against our impact, but ways that we can invest in R&D projects that will bring down the overall impact. At the heart of this plan is transparency. And although we're not perfect, we want to set ourselves on a journey that will reach the best way of launch possible. And we're going to do this by posting our activities online and having open engagement sessions with the public. Sustainability and responsible launch are not just about the environment. We're going to be working on a project called KernelSat, a community satellite. KernelSat will involve local stakeholders, including schools, academia, and the council, to develop a payload to launch on our very first launch with Virgin Orbit next year. This satellite will be designed, built, and launched in Cornwall for Cornwall. It will identify a local problem and a solution from space. It will inspire a generation of local school children and help to bring space down to Earth. Spaceports are the gateway to space, and we have a responsibility of what we launch to space, how it gets up there, and what it goes on to do for our humanity and for our planet. Here at Spaceport Cornwall, we want to lead the world with this challenge, and we are so excited to go to space for good. Thank you.
Hello, I'm Keith Coleman, the Chief Executive of SUSAIWI. We all know that our food production systems cannot feed our growing population sustainably. Agriculture already releases 4.5 billion tonnes of greenhouse gases into the atmosphere, consumes 70% of all fresh water, and costs 26 billion tonnes of fertile soil each year. That's not because of the plants, which naturally absorb carbon and deliver oxygen. It's because our food production systems are badly designed and out of balance with nature. We need new solutions. SUSAIWI's mission is to make the world's healthiest and most sustainable food. We do it by growing algae, completely naturally, delivering both abundance and climate balance. Ocean microalgae produce 80% of the planet's food, converting sunlight, carbon dioxide, and minerals into food more efficiently than any other plant. It makes the world's healthiest food and is the only organism that makes EPA and DHA, essential ingredients for healthy fish and healthy people. Algae grow 10 times faster than land plants, and to top it all, algae absorb 50% of the Earth's carbon and produce half of its oxygen. Yet the method to cultivate algae on any meaningful scale has been locked away. Until now. SUSAIWI has developed and patented a new technology to grow algae on a large scale for the first time. We grow algae naturally, using only sunlight, seawater and wind. SUSAIWI grows algae in the desert to make the healthiest, plant-based and most sustainable food on the planet. Dr. Rafael Javin, our chief scientist, observed algae grow in harmony with ocean and planet. His invention imitates the natural bloom process. When dormant algae is hit by a surge of cold, deep, nutrient-rich upwelling water, the algae move into exponential growth phase. They absorb the nutrients and carbon dioxide from the seawater and air, photosynthesize, grow and divide. As the upwelling continues, the algae grow and divide again. 30 days later, 20 kilograms of stationary phase algae becomes 10 million tons of food. As they grow, they respond to microsignals. When nutrient additions slow, algae produce more lipids like omega-3. Excess sunlight produces more pigments like beta-carotene. In exponential growth, they maximize protein production. SUSAIWI is different from conventional algae systems. We don't scale up an artificial test tube with artificial seawater and pumped in carbon dioxide. We scale down the ocean using natural seawater, nutrients and CO2. We work only with local species, no genetic modification, no artificial additives. We have tested and proven our technology on multiple species over the last 6 years. First in St. Helena Bay in South Africa, 300 times bigger in Oman, and then the largest algae growth pond in the world here in the Sahara Desert in Morocco. We start with a single species, chosen from the local ocean for its nutrient value, fast growth and large harvestable size. We grow those algae in flasks under lights, feeding them nutrient-rich seawater. The algae consume the nutrients, then divide, doubling in number. Then we transfer the algae to the greenhouse. We add more seawater and nutrients until the algae are moved to large outdoor growing ponds. After 30 days, our teaspoon of algae is the world's largest pond of algae, ready to harvest over simple screens, then desalted and dried in a low-temperature oven, ready to be shipped to the customer. Our next stage is a 100-hectare module that will produce over 1,700 dry tons per annum of sea plant-based ingredients. Our full-scale farm will deliver more protein than the world's largest chicken factories that produce 2 million chickens a week and emit 1 million tons of carbon and use 100 million tons of water each year. Our regenerative farm will produce 70,000 tonnes of dry algae per year to make carbon neutral plant-based food. We will absorb 230,000 tonnes of carbon dioxide. We don't use fresh water. We will make 450,000 tonnes of it and 70,000 tonnes of oxygen. And we will deacidify 3 billion tonnes of seawater per year, actively raising the pH of the surrounding ocean to pre-industrial levels and mitigating climate change. We will produce more protein per hectare than any other outdoor farm in the world in the desert. Because we use seawater, we are entirely drought resistant. If used for fish feed, we save 420,000 tonnes of fish being turned into fish meal per year. We are developing the tools to listen to the algae and monitor live the environmental signals that drive their behaviour. Co-funded by Innovate UK and working with some of the world's most advanced satellite modelling and AI companies, Susawi is building an intelligent monitoring and control system, integrating the most advanced digital technologies available to create state-of-the-art aquaculture. We are starting to use satellites to get live data feeds on the environmental parameters, like weather, shaping the growing conditions. We are monitoring sea surface temperatures, feeding these into a new finite volume community ocean model to forecast and hindcast nutrient quality of the seawater feeding the ponds. Satellites monitor the biomass of our ponds, which tells us how fast the algae are growing and the yield we can expect from each pond. At the heart of our technology is the digital twin, a sophisticated virtual simulation of our real-world system. It models the biology of each species, then designs aligned engineering and operations, and forecasts the financial returns we expect. Connected to live data, our digital twin is a control model. Through predictive modelling, SCADA and robotics, we alter the depth of the ponds, speed up a paddle wheel, top up natural nutrients, change the duration of dilutions. By using advanced digital technology, listening to the algae, and setting up learning loops using machine learning, within the next 3 years we will synchronize our artificial intelligence with nature's 4 billion-year-old accumulated wisdom. Within 5 years, our algae farm will produce more than the rest of the world's algae production put together. There is enough suitable land for 500 of our farms globally. With support from global institutions and powerful governments, we can turn coastal desert lands in the Gulf, Africa, Chile, Mexico, Australia, and elsewhere into production hubs of zero-carbon food. Nature is the greatest innovator, and we are unlocking algae, one of nature's greatest innovations. We will unlock the power of the sun to capture its energy. We will unlock the productive capacity of the sea with its abundance of nutrients. And we will unlock the wind in a form we can use for the good of both people and planet. Sun, sea, wind.
The aim of the Southwest Centre of Excellence in Satellite Applications is to help to grow the Southwest Space Cluster by supporting innovators and researchers to develop and commercialise space technologies and satellite applications for wide-ranging sectors. The Southwest Centre is part of the UK Space Innovation Network led by the UK Space Agency, Satellite Applications Catapult and the European Space Agency to bring together academic institutions, technology centres and a whole range of space innovation activities in order to tackle key environmental, societal and sustainability challenges and drive economic growth empowered by space technologies and satellite-derived data. Our partners include the Universities of Plymouth and Falmouth, and we work closely with Spaceport Cornwall, Virgin Orbit, Goonhilly Earth Station, Aerospace Cornwall and other business support initiatives to drive regional space-enabled impact. The global space market is predicted to reach £400 billion by 2030, and the UK is aiming to capture a 10% share. The University of Exeter is focusing on 4 key themes within the Southwest, capitalising on the distinct regional resources, capabilities and opportunities. Within the Southwest, our key space-enabled focus areas are e-health and e-wellbeing, marine and maritime, mining and natural capital. For e-health and e-wellbeing, satellite applications can deliver transformational change in a way that healthcare and wellbeing services are delivered, contributing to the overarching vision of environmental sustainability in many sectors and in all aspects of our lives. For marine and maritime, data from space is vital to the maritime industry, including tracking the location of vessels for the sake of safety and economic efficiency. It also has an important role to play in monitoring the marine environment and its sustainability. One current clean energy project that we're involved in is floating offshore wind farms in the Celtic Sea. For mining, satellite technologies can create operational efficiencies within the mining sector, whilst empowering local communities and improving environmental sustainability. For natural capital, remote sensing data can unlock the value of our natural capital, including agritech, environmental intelligence, and sustainable productivity, which can lead to diverse social, economic, and environmental benefits. Through our work, we have supported cutting-edge research and innovation initiatives across multiple key sectors and industries. We are also helping the Cornwall Wildlife Trust to use Earth observation technologies to monitor sand dune habitats in Cornwall, as part of a national programme to restore sand dunes for the benefit of people, communities and wildlife. We have also coordinated a collaborative satellite-enabled battery metal exploration project utilising machine learning techniques for satellite data to identify potential lithium-enriched areas within Cornwall for clean mobility applications. And we're also very proud to be working with Spaceport Cornwall to define the research questions for the first satellite launching from Newquay in 2022. Our researchers have also supported the development of Spaceport Cornwall operations by conducting beneficial carbon impact assessments. The Southwest Centre of Excellence in Satellite Applications is part of a much larger effort at the University of Exeter to harness the potential for environmental intelligence, to inform and shape the interventions that are needed to make a positive impact on climate change. We want to work with regional, national and international partners to realise the potential within our region and to meet the challenges and opportunities for space, satellite data and environmental intelligence.
Brief word about Astroscale. At this stage, we are totally focused on developing and implementing business cases and commercial solutions for a range of government and commercial customers to essentially address the current and future problems involved with promoting better use of space, sustainable use of space, minimizing environmental pollution in space. And we will do this through a range of in-orbit servicing missions, which I'll maybe touch on at the end of my short presentation. The area which I'd like to specifically focus on is the area of pollution of the overall planetary system, which is not just what happens on Earth, but the near-Earth environment. And up in that near-Earth environment, you have, within a few years, you will probably have 10,000 plus satellites in LEO orbits, plus many more in geostationary. And it is now pretty well recognized by at least the technical experts that we have increasing problems of space debris, which, if not mitigated, will cause or could cause runaway catastrophic effects, which would render parts of that orbital resource unusable for many years or many decades. And that's typically called the Kessler syndrome. In that context, various states, especially the leading states who are involved in spacefaring activities, have taken efforts at the UN level. And recently, say 2 years ago, they developed the long-term sustainability guidelines, which is essentially a set of voluntary guidelines which encourage states of the UN to do better. We strongly support the LTS guidelines, but we would like to propose that the states, in particular those of the leading spacefaring nations, including the UK and many of those who are present at the G7 summit here in Cornwall, to actually go beyond what is in the LTS guidelines. And in that context, what we'd like to propose is essentially to create a context which would be a new sustainable development goal. Slightly outside the UN framework, because it's challenging to get it explicitly into the UN, but to create a leading group of states and multi-stakeholders to create a new sustainable goal, sustainable development goal, which is called net zero space. So it would mirror essentially what is going on already on doing stuff and things to enable net zero Earth. So in that regard, we suggest the following items, and I'll give you a checklist, which we think would be huge enablers. The first is to improve the space situation awareness capabilities, which enables space actors to better predict and assess risks of their space activities. Secondly, to set specific goals by certain timelines, similar to what has been achieved in the Net Zero Earth context at UN and national levels. And those specific objectives would be to firstly require all spacecraft and rockets, which are launched, say, by beginning of 2025, to be capable of being removed from orbit, either to a graveyard orbit or deorbited safely into the atmosphere of the Earth within 5 years of end of mission. Secondly, that all spacecraft which are launched going forward within, the next, starting from, say, 2023 or slightly beyond that date, be equipped with capabilities which enable them to be removed from orbit when they fail, so they don't create a long-term hazard in those orbits. And one way of doing that would be to implement docking plates, as, for example, a UK-based company, OneWeb, has already done on its first generation OneWeb satellites. And that, we believe, is an excellent example which other space companies can take going forward. The other approach would be to use other remediation techniques which might enable life extension of those LEO satellites, which enable a safe continued existence in orbit while they perform their missions. The third area which we think is important is to tighten up and to be a little bit more candid, to toughen up the rules on what constitutes acceptable behavior in space and acceptable or reasonable measures to assess risks, and in particular with the explosion or large increase in LEO satellites, which is happening, hundreds and thousands of satellites expected to be launched in the next 5 to 10 years. A better risk assessment method is needed, and we believe that the risk assessment posed by individual satellite constellations, large constellations, should be based on some metric which assesses their overall aggregate system level risk to the environment. And only then can everybody understand what is the total risk. So those are the three main measures in the near term. We also suggest and recommend that states and major actors take steps through PPP, for example, activities to go after the largest space debris derelict objects, which are typically 1 ton or bigger in size, which is floating around. From a company point of view, Astroscale, we're already taking steps in this regard. Earlier this year, in March, we launched the ELSA-D mission in LEO orbit, which is demonstrating our capabilities to do in-orbit attachment, detachment, and removal of a cooperative space object. We earlier this week signed a contract working with OneWeb and European Space Agency with UK Space Agency support to go to the next step, which is to do an actual demonstration with a live satellite of a commercial operator, which is OneWeb, and that is planned to take place in around 2024. The third element is that our Our company, our sister company in Japan, is working with JAXA, the Japanese Space Agency, to undertake preparatory steps to essentially go after and attach to a large third stage rocket, which is the other category which I mentioned. And these are all steps, not baby steps, these are big steps. Okay, where we are demonstrating a capability at Astroscale with our partners to do these activities going forward. And we look forward to cooperating with you and with other institutions on these matters. Thank you very much.
Goonhilly Earth Station is pleased to be part of the Truths Consortium. The Truths mission brings an opportunity to develop skills and capability to fill future jobs that will increase as a result of the mission. With previous experience in developing and delivering training courses, in STEM outreach, and in a facility that supports spacecraft communications and data processing, Goonhilly has an understanding of the importance of skills in a growing sector. If the future skills need isn't addressed today, the benefits, technology, and functionality resulting from missions such as Truths won't be realised. With Truths as an inspiration and providing career options, children today in the UK and participating states can see how their STEM education is relevant. An 11-year-old student could be inspired to follow an apprenticeship pathway that includes work on the build of the spacecraft, or they could follow an education path through university and postgraduate study, completing their PhD using data captured through the Truths mission. Today's 16-year-olds could be working on the spacecraft build after completing an apprenticeship, or post-graduation could be working in a role that supports the launch of the mission. Graduate engineers needed to work on the mission will be studying at university today. This is why Truths is so important to Goonhilly, the UK, and other participating states. It provides a tangible mission that can be used as an example for job roles, careers, and collaborations. It has a timeline that makes working on the mission a real possibility for children that our outreach activities will engage. It will create jobs and opportunities, combining science, technology, and data. Indeed, there is a broad range of subjects that Truths can touch, including science, maths, geography, metrology, and not to mention a raft of engineering disciplines required to build the spacecraft and related infrastructure. Our goal in this early stage of the mission is to make sure people, children, adults, teachers, employers, know about Truths, and to create opportunities for students to build experience, useful skills and capability for future jobs. Some examples of these will be through apprenticeships, school resources, projects and placements, and formal training for those already in employment. Goonhilly Earth Station is building skills and capability in satellite communications, data science, and ground segment operations, using Truth as the inspiration for the future generation.